Humans have declared war on animals before, with machine guns, continent-spanning fences, and recruited biological weapons, and lost every single time. In 1932, the Australian military mobilized against emus and was forced to retreat. The animals didn't need generals, battle plans, or strategy rooms. They needed only what evolution had already given them.
Western Australia, 1932. Open scrubland, flat and vast, and moving across it, a living tide of approximately 20,000 emus, migrating as they always had, following ancient instinct toward farmland and water.
The government's response was swift and, on paper, decisive. Soldiers arrived with Lewis guns, military-grade machine guns capable of firing hundreds of rounds per minute. The objective was clear: reduce the emu population, protect the crops, and demonstrate that the problem could be managed. It read like a straightforward operation. It was not.
Human objective: reduce the emu population and protect farming land. Animal advantage: speed, terrain, and instinctive scattering behavior. Turning point: a Lewis gun is devastating against a massed stationary target. The emus never gave the soldiers one. The moment pressure arrived, the emus did what emus do: they split. Not as a tactic, not as a coordinated retreat, simply as birds moving the way birds move when threatened. Small groups peeled off in every direction across enormous stretches of open terrain. Soldiers who had expected to engage a concentrated flock found themselves firing at scattered silhouettes disappearing into the scrub. The guns were loud, the results were not. The operations commander noted that even after being hit multiple times, the emus kept moving, comparing them to soldiers carrying the bullet capacity of an entire military division and describing them as facing machine guns with the invulnerability of tanks. The campaign was called off, restarted, and eventually abandoned. The emus remained, the crops remained unprotected, and the story found its way into parliamentary debate, which is perhaps the most human way possible to confirm that things had gone badly wrong. Result: mission failed. Field note: never underestimate a bird that runs like a dinosaur. The emus had no plan. They had no general, no counter-strategy, no awareness that a military operation had been mounted against them. They simply moved the way evolution had built them to move, fast, scattered, and indifferent to the inconvenience they were causing, and that was enough. Which raises an uncomfortable question the next case makes even harder to ignore. What happens when humans try to solve the problem not with guns, but with engineering? If guns couldn't hold the line, surely a wall could, a permanent one that crossed an entire continent. Construction of the #1 rabbit-proof fence began in 1901, stretching 1,834 kilometers from the south coast to the northwest coast of Western Australia. When it was completed in 1907, that fence was the longest unbroken fence in the world. Workers moved through some of the harshest terrain on Earth: desert, scrub, salt flats, burying wire netting into the ground to stop rabbits from tunneling beneath it. It was an extraordinary feat of human engineering. On paper, it was the answer. The rabbits did not read the paper. Human objective: build a wall nature could not cross. Animal advantage: explosive reproduction and a head start no construction crew could outpace. Turning point: the fence wasn't finished yet, and the rabbits were already on the wrong side of it. By 1902, rabbits had already been found west of the fence line, while workers were still hammering posts into the ground further north. Rabbits had breached fence #1 before its construction was even completed. The biology simply refused to wait for the schedule. A rabbit doe can produce several litters a year. The population doesn't pause for infrastructure. It doesn't consult a map. It just moves, eats, reproduces, and moves again, indifferent to the fact that several hundred men and a workforce of camels are racing to get ahead of it. A second fence, #2, was built in 1905 in an attempt to stem the advance, then a third. When all three were complete, the rabbit-proof fence system stretched 3,256 kilometers, 3 fences, 6 years of construction, an enormous expenditure of labor and money, all chasing a population that had already moved past the original objective before the first fence was done. Result: outpaced. Field note: population multiplying faster than humans can build. This is the part worth sitting with. The fence wasn't a bad idea. It was a genuinely ambitious, technically impressive response to a real crisis. The failure wasn't laziness or poor planning. It was something more humbling than that. The rabbits didn't outthink the engineers. They simply outran the calendar. Biology operates on its own clock, and that clock does not pause for construction schedules or government commissions. The emus won through chaos. The rabbits won through reproduction. Both victories were passive, pure instinct, no awareness of the conflict at all. But the next case is different, and in some ways darker. Because this time, humans didn't try to stop an animal. They deliberately recruited one as a weapon and handed it the keys to an entire continent. The rabbits were already past the fence line before the last post was hammered in. So which case do you think was the more embarrassing defeat? The emus scattering the soldiers or the rabbits outrunning an entire continent's worth of engineering? Drop your answer in the comments below. Either way, the next case makes both of them look like a fair fight. That sketch of a toad-stamped biological weapon is not a joke. That was the actual plan. Queensland, 1935. Sugarcane crops across the Northeast were being devastated by two species of beetles, specifically their larvae, which fed underground on cane roots. The solution, as the agricultural authorities saw it, was elegant: import a predator. The cane toad had been used in other countries as a form of biological pest control. It ate insects. It reproduced reliably. It seemed on paper like a recruited ally rather than a gamble. Human objective: deploy a natural predator to eliminate a crop pest. Animal advantage: the toads ignored the beetles entirely. The larvae lived underground, out of reach, while the toads hunted at the surface. Meanwhile, the toads reproduced at a rate the original plan had not fully accounted for, spread rapidly across northern Australia, and carried parotid glands packed with a toxin potent enough to kill animals that tried to eat them. Turning point: the weapon did not fix the original problem, it became a new one. 102 cane toads were imported from Hawaii in 1935, bred in captivity, and approximately 2,400 were released into northern Queensland that same year. Within decades, the population had expanded into the millions, spreading west across Queensland and into the Northern Territory. Native predators, quolls, goannas, freshwater crocodiles, had no evolutionary experience with the toad's toxin. They encountered something new, tried to eat it the way they had always eaten prey, and died for it. The cane toad had not set a trap. It simply existed, carrying chemistry that evolution had built long before anyone in Queensland had a beetle problem. Result: backfired. Field note: when you give nature a new piece, it plays by its own rules. The emus scattered. The rabbits outran a construction schedule. Both of those were passive victories, biology doing what biology does, indifferent to the human operation running alongside it. The cane toad case is something sharper. Humans didn't just fail to stop an animal. They imported the problem, named it a solution, and released it into a continent that had no defenses against it. The weapon was never the toad. The weapon was the assumption that nature could be directed. It is an assumption that the next case will test even more directly, because the cassowary doesn't need numbers, poison, or a continent to cross. It only needs you to get close. After the cane toad, the scale shifts entirely. No migrations, no continent-wide spread, no poison moving across a map, just a rainforest, a single bird, and the moment a human makes the wrong decision. The cassowary lives in the tropical rainforests of northeastern Australia and New Guinea. It stands nearly 6 feet tall. It can sprint at up to 31 miles per hour, leap up to 5 to 6 feet off the ground, and carries talons that grow up to 5 inches long. The casque, that hard bony ridge rising from the top of its skull, looks prehistoric because functionally it is. This is not a creature that evolved to lose close-range encounters. Human mistake: treating a wild animal like a pet, a photo subject, or a challenge. Animal advantage: speed, powerful legs, territorial instinct, and a single dagger claw that ends the conversation. Turning point: there isn't one. The cassowary was always going to win this exchange. The only variable is whether the human created the conditions for it to happen. A historical study recorded 221 cassowary attacks against humans and domestic animals. Of the 150 attacks against humans, 75% involved cassowaries that had been fed by people, and 73% of incidents involved birds expecting or soliciting food. Feeding cassowaries appears to change their natural behavior, making them bold and aggressive. The cassowary did not decide to become a problem. Humans handed it the expectation of a meal, and then were surprised when the bird arrived to collect. Most attacks involved cassowaries that had been fed by humans and were expecting or soliciting food. 73% of incidents, not primarily birds defending food, chicks, or eggs. And in 75% of cases, people had previously fed the birds. The pattern is consistent enough to read as a rule. The encounter is almost always a human creation. The cassowary is simply responding to the situation it was placed in. Result: respect. Field note: do not feed, do not corner, do not crouch. This is where the through line takes a quieter shape. The emus needed 20,000 bodies. The rabbits needed a continent's worth of reproduction. The cane toads needed poison and a government release order. The cassowary needs none of that. It wins by being exactly what it already is, occupying exactly the space it already occupies, and waiting for a human to step into that space uninvited. The war here was never declared. It was stumbled into, usually by someone offering a piece of fruit, and that might be the sharpest version of the through line yet. Nature doesn't need a campaign. Sometimes it only needs you to make one mistake in the long rainforest. The cassowary doesn't need numbers, poison, or a continent to cross. It only needs you to get close. A dark farm at the edge of a national park somewhere in Kenya or central India. No soldiers, no guns, no government permission, just a broken fence, a flattened row of crops, and the enormous silence that follows a herd that has already moved on. Human-elephant conflict is driven primarily by habitat loss. As land is developed for agriculture and settlement, elephants are forced to compete for the same resources. The farms didn't invade elephant territory. The territory was already theirs. The farms simply arrived on top of it. Human objective: keep elephants away from crops using fences, noise, lights, and patrols. Animal advantage: intelligence, memory, and the quiet patience of an animal that has been navigating this landscape for millennia. Turning point: there isn't one. That's the point. As elephant habitats shrink, elephants are progressively forced into closer contact with people, resulting in more frequent and severe conflict over space and resources. Farmers have tried everything: yelling, setting off firecrackers, hitting metal objects, throwing stones. Lights get ignored, noise gets learned. Electric fences get tested, and then tested again by the same bulls who figured out the pattern last season. A single elephant makes light work of a hectare of crops in a very short time, and then it walks back into the dark, carrying the memory of exactly which fence gave way and which one didn't. This is where the elephant's advantage separates itself from everything that came before. The emus scattered on instinct. The rabbits outran a calendar. The cane toads simply existed. The cassowary had its body and its patience. The elephant learns. It teaches. A matriarch who has navigated this landscape for 40 years carries a social memory that no fence can erase. Which is why the only deterrent that has shown real promise is the one that works with elephant behavior instead of against it. Elephants avoid disturbed African honeybees. They move away from bee sounds, make alarm calls to warn family members, and keep a safe distance from beehives. Researchers harness that instinct. During 6 peak crop growing seasons, beehive fences successfully deterred an annual average of 86% of elephants from raiding crops. Across all seasons, the average was 76%. To date, over 14,000 beehives have been hung as elephant deterrents across 97 sites in Africa and Asia. Result: no simple winner. Field note: against intelligence, walls are never just walls. And here is where the through line of every case closes into a single shape. The emus had speed, the rabbits had reproduction, the cane toads had poison and a government release order, the cassowary had a 5-inch claw and the patience to wait for a mistake. The elephant has memory, deep, inherited, socially transmitted memory that outlasts any individual human plan. In every single case, the animal's advantage was already there, built in, assembled over thousands of generations, long before anyone arrived with a machine gun, a fence blueprint, a crate of toads, or a patrol schedule. The animals didn't adapt to beat us. They simply continued being what they already were, and our plans ran out of runway. Nature does not always fight back loudly. Sometimes it simply survives long enough for our plans to fail. Subscribe to Creature Field Notes and watch this one next.